Hi everyone, welcome to our first talk today, Saturday in Los Angeles V. First a word from our sponsor. It's from MaxCDN. MaxCDN is a next generation content delivery network based in Los Angeles. The whole team is obsessed with speed, automation, real-time reports, and implementation. And if you want some bandwidth through their CDN, go ahead and head over to maxcdn.com for a free trial. Our first talk is going to be from Dustin Kirkland. It is rapid video transcoding on an Ubuntu Orange box.
Thank you very much, and thank you for the patience. Over the last few minutes, I was setting the box up. It involves a bit of setup to get it to the point to where we're ready to demo this. So, if you came early, you get to see a little bit of the guts of this behind the curtain. So, out of curiosity, who's here to learn about transcoding? Who's here to see the orange box? That's what I thought. Very cool. Absolutely. That's slide 17. We're going to get to that. Has anyone seen Code Rush? Old documentary, old 2000 documentary. The IMDb entry right here. It's 7.4. It's a pretty good documentary. It follows what happened with Netscape Navigator after AOL acquired Netscape. Right around 98, 99, 2000 was when Microsoft put IE directly into the operating system, right? And now, it's hard to imagine a browser that's not part of your OS. But when Microsoft did that, they were sued, antitrust litigation, major antitrust litigation, because a browser was a product that was not part of the operating system. And so Netscape's reaction to that was actually to open source Netscape, and that's very apropos for our conference here today at Scale. We're celebrating open source, and Netscape was one of the first and the biggest and most user-facing pieces of open source software out there. Code Rush itself, in the spirit of open source, is actually licensed under a CC, a Creative Commons license. You can download Code Rush so Netscape became Mozilla, and Mozilla is what we know today as Firefox, just sort of linking the chain. If you've never heard of Netscape or wondered about the how that came about, you should definitely watch the movie. And the movie you can download for free. You can go to archive.org, Internet Archive, and there's a link right there where you can start downloading it this very instant. CC by NC-SA, which means it's Creative Commons. You can download it for free. You can't sell it, and if you share it, you should have to share it with the same license. And it's wonderful. You can download it in 3 different formats. In fact, MPEG, a little bit bigger MPEG, and OGG video. Now, when I did that originally in my Firefox browser, I was absolutely baffled by this error. This is a Firefox browser trying to watch, and this is a modern Firefox browser, Firefox 21 in Ubuntu, a modern Firefox browser downloading the movie about the coming of age of Firefox, freely downloadable in free formats, I thought, and I wanted to play it on my system right here, and this is what I saw. In fact, you've probably seen that message before and wondered, WTF, right? It's a family-friendly conference, so which transcoding format is this, right? That's what you were thinking. Okay. Which transcoding format? Why do I even have to think about this in the modern era, in the modern day and age? It's actually really complicated, and this chart oversimplifies it a little bit. I got this from the W3C, the W3 consortium. It lists a couple of browsers, IE and Chrome and Firefox, Safari, Opera, and then the various formats and what's supported and where. And look, there's some caveats here, and you're trying to wonder about this. Does anyone manage content? Our sponsors we heard from do CDN, content distribution, manage content on your site. Compatibility across browsers is important, certainly, right? And you put a lot of effort into the HTML and the JavaScript and the CSS to make sure that all comes together. But guess what? The new web is less about the static content and so much more about the dynamic content, the videos and and the audio and the interaction with it, right? And it's actually kind of complicated to get it right. And these are 3 different ways of sharing videos and how they're supported in HTML5 compliant browsers. Now, you'll see a bit of a very important footnote, in fact, down here. Video formats, there's more to it than just the extension, just .mp4. If we go back a couple of slides, you'll see very clearly that what I'm downloading is a .mp4, and that's supported in Firefox, right? Look, MP4, Internet Explorer, Chrome, Firefox. Look, this column has the most yeses, so it clearly must be the best. Does anyone use Opera anymore? I don't even know where to find Opera. But look, we got yeses across the board. Got a few caveats right here. What went wrong, right? There's a couple of pieces to a video format. One of them is the container. And I'm going to oversimplify this a little bit just because we could have an entire session on video formats. One of them is the container, and that's usually what we think of as the extension. So the MP4 container, or the WebM container, or the OGG container. And then in a video, there's at least 2 different portions, 2 different streams inside of that video. There's the video, and there's the audio. And they're both encoded using different codecs. Codecs are a way of compressing video and audio so that it can be transmitted and used efficiently, right? So H.264 is one video codec. We can call it the leading free-ish codec. You'll also see this in Linux referred to as X.264. The important aspect about it is that it's very modern, it's very fast, it's very efficient, and it's very high quality. You can actually transmit really good quality high definition in H.264. From an audio side, there's also an audio codec that is managed separately, but those 2 are combined together in a single into that single stream, into that single MP4 stream. So I ran avconv, which is it's sort of a fork of ffmpeg. A lot of drama in the open source community about ffmpeg. It became avconv, and now ffmpeg is back. For the sake of this talk, everything that I've done here is avconv, which is a derivative of ffmpeg. You run avconv-I on any given media file, and it'll tell you a bit of information about it without playing it or transcoding it or anything. And I can see right here very clearly this is an MPEG-4 video. That's great, right? So far so good. And I can see here that my audio is an AAC compressed audio, and that's great, right? But then there's the kicker. This video was encoded in a YUV420p stream. YUV420p is a way of picking the color in the pixels and defining what's going on in that video at a given time. The important thing is that says YUV420p and not X.264 or H.264, which means we need to transcode that video. We need to take it from one format and turn it into another format. And I'm sure you've seen this. These are screenshots from iPhones and tablets and browsers and various operating systems, and it all sort of says the same thing, one way or another. Look, we can't play this video, which is just so annoying, so frustrating, right? So here's a magic command that you can run on any Ubuntu system where avconv is installed. libav is the open source project. apt-get install libav tools. You run avconv on an input file. You tell it the video codec is libx264. That tells it which library to use. Which audio codec? AAC. Another really complicated option that basically says we're going to use H.264 inside of an MP4. The output format is going to be an MPEG stream. I need that for the demo that I'm going to do later. That's not necessary in all cases. Strict experimental, it says to use these 2 together, and yes, overwrite that file if it exists. You can run that on any video. In fact, I took that CodeRush video and ran it on my shiny laptop right here. It's a dual-core, hyper-threaded i7, so high-ish end on the desktop side of things, but certainly not a workhorse workstation or anything like that. And that took 23 and a half minutes to transcode, a 60-minute long video, an hour-long video. In fact, I also just last night transcoded the same exact file on one of the nodes on this machine, just a single node, right? Just one node. And it's an i5 with a little bit more RAM, a little bit more. This is very much a CPU processor bound and IO bound process. Again, it took 21 minutes on a single system to do that. But I actually have a cluster of machines with me, a cluster of physical systems. So this is the orange box portion of the talk. This is the Ubuntu orange box. Has anyone not heard of the orange box before? This is your first. Awesome. I love talking about this. So it's a striking machine, isn't it? I mean, it has it just pops, right? What is it? It's actually a portable cluster. Let that sink in for a minute. There are 10 physical nodes inside of this chassis. It weighs 20, 30 pounds or so. It fits in this flight case. I fly all around the world with it. In fact, we've got a dozen or so of them at Canonical, and our sales engineers have one with them at all times. We send them to conferences. We put them in booths and in settings like this. We'll even loan them or rent them to customers and partners sometimes when they need some equipment to do some testing or development on. So it's 10 nodes. The nodes themselves are Intel NUCs. Anyone have an Intel NUC? Tiny little machine. Yeah, they make great little video gaming boxes or little boxes attached to your TV. I bought about 3 of them a little over a year ago and started playing with them, and I made a very small OpenStack cluster out of the 3. I blogged about it, and I work for Mark Shuttleworth, who has a bit more resources than most of us in the room, and he said, that's awesome, go find a way to put 10 of those in a suitcase. I want 10 of those in a suitcase, and I want to wheel them around. And this is what came out of that challenge. So every single node has a dual-core hyper-threaded i5, so it looks like 4 CPUs to the operating system. Every single node has 16 gigs of RAM. Every single node has a 120 gig SSD inside and a gigabit NIC. There's a 16-port switch, gigabit switch on the inside. It's a managed switch. We can do some fancy stuff with VLANs and network shaping. Half of the nodes have additional storage, and the master node, one of the nodes, has Wi-Fi. It has an extra NIC, and it also has its outputs wired to the back. Oh, and it also has a 2 terabyte spinning media hard drive, which we use to cache a bunch of data on the system, so that we can take this around and not use the network as much. That's sort of what it looks like underneath. All the nodes themselves, the CPU and the GPU fit up against the aluminum heat sinks on either side. So none of the nodes, not a single node, has a moving part, which is pretty amazing. The only moving parts are there's one fan in the back which cools the power supply. There's a single 20-volt power supply that sends 20 volts to every one of the boards. We use the pin-on headers for each of the boards. And that one spinning media 2 terabyte hard drive. That's the only moving parts in this whole system. It's silent. This thing's running at full bore right now, and I mean, unless you're standing right here, you really can't hear it. I keep this on my desk sometimes, and it'll run all day long. It tops out at about 210 watts. The power supply is rated for 300. The most I've been able to draw is about 210 watts. And it's not something that we sell. You can buy them. They're about $12,000. We have them custom made for us from a company in the UK called Tranquil PC. Canonical's not in the hardware business, but we had these boxes built for us on a contract so that we could fly around with a cluster. In about 10 minutes, we can deploy almost any workload you can imagine on this. Hadoop, we can wipe everything off of it and then deploy OpenStack, wipe that away, deploy Kubernetes, wipe that away, and deploy Transcoding, which is what we're looking at here today. Any questions about the hardware? I'll pause for a second. What's that? Yeah, it's expensive. It's a little pricey for the home server, but for what we're using it for, it's great. It's an incredible machine. Yes, sir. So it varies in different configurations. We've actually moved from secondary SSD to actually little tiny flash drives that we just plug into the USBs on it. All we really want out of a second disk in our configuration is to have 2 disks on a system, so that especially in OpenStack workloads where you want to put you need a root disk, but you also need a secondary disk as your victim for Swift storage or Ceph storage or something like that. That part is totally configurable and optional, I guess is what I'm saying. You can build one of these boxes at tranquilpc.co.uk and put however much storage you want in it. In ours, we have a 120 gig SSD and a 32 gig flash media, so real small. That's really not the interesting aspect of the Orange Box to us for our purposes. Hardware questions?
They actually will build one.
Yeah, absolutely. They'll build it and ship it to you, and I think it's 4 to 6 weeks lead time. There's a I don't know how many of them there are in the wild. I'd imagine a few dozens, maybe a couple of hundred. They're quite useful in places where you need portable compute. I know of a company using these in oil fields in Texas where they've got big data and lots of data, but getting gigabytes of data off of an oil rig outside of 500 miles away from Lubbock, Texas is kind of hard to do, so they can crunch the numbers on the box local and send the answer. Yep, there's oil here. Hi. Come drill a bigger hole.
Can you elaborate on the graphics card?
Yeah, so there's not much of a graphics card in this. It's an Intel 3000 GPU. It's onboard Intel. Yeah. In fact, we're not using GPUs in the demo here today. So it's not all that impressive. There's certainly better graphics GPUs out there. There is one. It does okay. It keeps up. So here's what we're doing today. We're taking Juju, which is service orchestration, open source service orchestration developed by Canonical. It's a very intelligent way of deploying workloads to public clouds, private clouds, and bare metal. And here today we're deploying a workload, libav, our transcoding software, through something called MAS, another open source project from Canonical. MAS stands for Metal as a Service. What MAS does is it puts basically a REST API on a data center of hardware. This is a very tiny 10-node data center, which might be as big as your home office or small business. But MAS can also put that same API on tens of thousands of physical servers. And then what Juju does is it asks MAS, give me a machine or machines that look like this much RAM, this much CPU, put those workloads here and tell me when the system comes up. So what MAS does is MAS itself is a collection of a bunch of open source software that runs a DHCP server, a DNS server, a Pixie server. There's a Squid proxy. It's everything that you've probably set up in a small network where you're the network administrator, but it's one apt-get install MAS away, as opposed to going and finding and configuring bind and configuring DHCP and configuring Pixie. It's all that done for you perfectly. As this gentleman asked right here, just because I'm doing it in an Orange Box and you don't have an Orange Box yet, you actually can use the same open source Juju, the same open source charms, and deploy that same workload to either bare metal if you have it, or any public cloud. Amazon, Azure, Google Compute. We've got a list of others. Joyent, SoftLayer. There's, say again? HP Cloud, absolutely. And OpenStack. Actually, I neglected to put OpenStack on this slide, and that's one of our most important clouds. And that one's important because you can run it locally. You can run it privately. Anything that you can deploy with Juju, and there are hundreds of charms. George and Marco here in the back are authors of dozens of these charms. They've written many of these charms. Any workload that you can deploy with Juju, the beauty of Juju is you write that charm once, and then it deploys everywhere Juju works, and that's public clouds, private clouds, and bare metal. So this transcoding thing, if you've got an account in any of Amazon, Azure, Google Compute Engine, you can set this up and deploy the same job yourself in a matter of minutes. But here what we're talking about is MAS and Juju. So MAS, Metal as a Service, but Juju is going to do the deployment itself. I'm going to switch over into the demo mode in a second, but I captured this just to talk through a little bit of what we're going to see before we dive into it. So the design of what we're doing here is transcoding a video, and we need shared storage for all of the nodes. So all of the nodes, one of the nodes is going to run an NFS server. right? Anyone use NFS? I still use NFS at home. I got all my media and videos and pictures and everything shared around the house on NFS. It's quick, it's simple. Most importantly, you can set it up so that everyone can both read and write to it. A lot of the other ways of sharing file systems, it gets real difficult to do concurrent reads and writes, but NFS actually works pretty well at that. There's a lot of things it doesn't do well, but that's one of the things it does do well. So we've deployed NFS to one of the nodes, and it's exporting some of that 120 gig SSD storage, right? If you did this in production, maybe you'd want to put the NFS server on your system with tons of storage. Here, we're just talking about a couple of fairly small files we'll transcode. The transcode charm, you can run that on a single node, which is what I did when I timed it at about 21 minutes. Or scale that out. I'm running it on almost all of my nodes. I got one dead node here, so we're gonna just like any real data center, you have some nodes that die or they're sick and need a new disk or RAM or something like that. We've got one node that's misbehaving right now. We can also set up Ganglia or Munin or Nagios or any of your monitoring systems that Juju already supports to monitor these guys. And I did that last night, and or sorry, not last night. I did that recently, and you can actually watch the job come across and see the network traffic, the CPU load, the disk I/O, and you can watch your jobs and how they spike. Monitoring is a beautiful thing. It really makes a geek like myself get pretty excited. All right, so who's ready for the demo? Right? All right. Let's see how this works. So I'm going to flip over to a Firefox browser here. And in fact, I'm going to show you just what we saw. So if I hit F5 and try to refresh this page, I've got coderush.mp4, and I get this message from Firefox. Video can't be played because the file is corrupt. Well, it's not corrupt. It's just you don't know how to read that file. So what I'm going to do is I'm going to jump over to my Juju GUI. Juju has both a GUI and a command line, and for some reason I don't have icons today. I'm sorry about that, but trust me in that this is transcode and this is NFS. And if I click on the transcode, first of all, let's kick this off. So if I click on transcode and I go into the configuration of the charm, Marco? Service settings, transcode. That's not working for me. I can run it from the command line.
Yeah, run from the command line. Everyone loves the command line, right?
Yeah. So normally we can just type a URL in right here, but that's not working. Of course it's not going to work. We're in a demo situation. So on in the transcode charm, there are some configurable items in it. Juju get transcode will tell me what's configurable. And here I have a URL to something that I would want to transcode. Now I'm going to actually change that to our code rush. So I'm going to run Juju set. Help me. Transcode. Input URL equals. And I've got a local copy of that code rush, the one that we just tried to do so we don't saturate their network. I'm going to set that value. And that's going to kick off a job. So I'm going to very quickly jump over to one of the nodes, and I see a brand new job just pop up in this job directory. So I'm going to click on this, and I'm going to refresh a couple of times. First of all, the URL is set to that, and let me just make absolutely sure that's the right URL. Yep, that's the one that we can't play. And I'm going to refresh this a couple of times. Did that take all the way? The Juju set?
Yeah. Set and forget.
Okay. We'll need to give this a second. What it's going to do, it should download that file, and start the transcode process. So let's take a look at what the transcode process actually looks like, what the source code looks like. So one thing I was surprised when I started. All right, hold on a second. Let me do this instead. Is that a little better? Okay. So one thing I was really surprised by is that it was actually pretty hard to find a transcoder that worked well in a parallel, scalable manner. I had a bunch of nodes, and what I'd like to do is chop up some videos into much smaller pieces and do that transcoding itself. There's something called Handbrake that supposedly works pretty well. I had trouble getting that to work well, at least on my cluster. So what I did was I sat down, I thought about it, and myself, yeah, it was about 23 minutes.
I've used Handbrake on that same machine, and it cooks the processors at about 85, 90 C for about 3 hours.
Yeah, you're welcome to come up and touch this when you'd like. This runs just as cool as a cucumber. It really is a nice, cool, efficient. Let's see. All right, we got some tearing here, so I need to take a look at that. That didn't happen yesterday. But I'll tell you what we can do. We can look at our logs and get a feel for whether we had errors or not. And yeah, look at this. We have error, header damage, not working. Right. We can try a different video, and let me kick that off in the background. We'll start transcoding something else, and then I'll take a couple more questions. So let's see, README. Here's some examples. Has anyone seen Big Buck Bunny? It's won some awards back in the day for some really impressive rendering. So let's run that. So Juju set Juju get transcode. Actually, I got the whole command right here. And look, we're going to actually resize this one from 1080p to 960 by 540. So I'm going to run that command. That might take a minute to download since it's going out to the internet. And that job is now going to start here in the background. Any other questions while this runs? Slides, yeah, so Scale is publishing the video of the talk and the slides. I just exported the slides to PDF. If you follow my Twitter or my blog feed, I'll publish them there too immediately after. So, yep, code's everything you saw here is 100% free and open source code, all of it. Juju, Maz, Ubuntu, libav, the charms, everything it took to put this together, with the exception of Google Docs, I think is completely 100% free and open source code. And the bash, absolutely. Yeah, so it needs to operate on a complete file. So you'd need to break that file at points, like if hypothetical. I think they've got a pretty sophisticated setup here. I know Elon works on video for his day job. So I think they've got a pretty sophisticated setup. But let's say I'm speaking in this camera. If that camera were to take snapshots in periods in time, it absolutely could work on those snapshots and have them up very, very rapidly. And you could do that in the cloud and so forth. In fact, the way this actually came about, I was here in Los Angeles about a year ago at Digital Film Tree, who's a big OpenStack user. So Digital Film Tree is based in Hollywood. They have a couple of products used by some of the film studios to for editors to comment on a video while it's in production, right? So they shoot some video, and then editors go through and can mark up, hey, there's too much zoom in here, tighter crop there, change the color here, whatever. And while I was talking to them, I was really curious about what kind of tools they were using, and I made a comment like, yeah, I'm sure you guys have some really fancy transcoding. I just use ffmpeg, and they got really quiet, and they said, we use ffmpeg. And so I thought about it. I was like, oh, well, great. So what do you do for like your parallel transcoding with ffmpeg? They said, we don't. We just put a big machine behind it and give it a bunch of time and let it go. And so I said, have you ever thought about trying to parallelize that? And they said, no, we haven't. So that's where this came from, and it was a kind of a weekend hack. The other screenshot here, which I got pretty annoyed with, was this sort of situation, where I've got two little girls, and they like to watch movies, and having videos that I've purchased and trying to play it on different devices, it just drives me nuts when the format breaks, right? And so what I decided to do was go through everything, and I did a bit of research on what was going to be the format that worked with. It's not good. I did a bit of research on what format was actually going to work with most of their devices, and that's sort of how I settled on the MP4 H.264 AAC, and so I just transcoded my entire library to that. That and all the videos that we take in with our phones and our digital cameras, you go through. Some spit out MOVs, some spit out AVIs, and I just kind of took it all down to MP4. Yes, sir. Good question. So Matroska is MKV, I think, and so that's a different container format. So that's sort of the outer shell wrapper. I think with Matroska you can use H.264 and you can use AAC inside of Matroska, but the container format, the wrapper, is not an MPEG, not a motion, not an MPEG. That's as far as I can go on that question. Sorry.
A couple of questions.
Yeah.
Do you find any issues when you're parallelizing the fact that you actually split the file up and you're concatenating?
Yes, I was hoping to do that. I was going to do the math on. I see that it looks like my computer just went to sleep, and I'm not sure why. So what I like to do when I do this talk is actually do the math. How long is this video? Divide by 7. Find the seam. And what I've experienced is that most of the time you can't even see it. If you know what you're looking for and you're right there and you watch it a couple of times, you'll go, oh, maybe that was a little seam. More so when there's a lot of motion. It's a football game or something like that.
Is that specifically because of where it decides to put keyframes?
I think so. I think it's part of just the concatenation process, right? This job ended here, stopped. The next one started there. It's right now has a resolution of 100th of a second, but sometimes that's not enough to take care of really high res video in frames. Would I do this in production for the most important? Thank you guys for being here. There's also a talk about Netflix, next door. I'm sure they've got something much more sophisticated than this, and I think if someone wanted to put a little bit of effort into it, this is a 90-line shell script, right? I think if someone wanted to put a bit more effort into it, you could probably productize this into something a little bit more robust. This was a weekend hack on a Sunday morning after I'd just come back from Europe, and I woke up early in the morning because that's what you do when you're jet lagged, and I said, I'm going to try to hack on that transcoding problem I've been kicking around. So yeah, I mean it may not quite be the quality that you would want or expect in something production. I actually think the pixelation and distortion that was coming about there is because my laptop's in 1280 by 720 right now, and I'm being required to do this in 1024 by 768, and things are a little weird.
Just checking on.
Oh, yeah. So I'm sorry, I had an X Windows crash. Sorry about that.
Kind of related. What was the overhead on the concatenation?
Yeah, extremely fast. really just as fast as it takes to read and write that amount of data over the gigabit network. So when we did and my screen's frozen, so we're going to stare at this. But when we did the math on that, it was 21 minutes, right? And then we looked at how long it took, and then I think what I saw was about 3 minutes and 20 seconds, so a little over the 3 minutes that we had estimated. That 20 seconds was basically how long it took to read and write that 200 meg file or so. Gigabit's fast, but it's not as fast as local storage. SSDs are fast, but SSDs over gigabit is not as fast as local storage. A good SSD, you should get about 6 gigabits per second throughput, and on a network, you're 1 gigabit. So, yeah, that part was the fast part. You do this on a much larger, bigger video. For the sake of this demo, I carefully chose, well, for this crowd, I chose the Code Rush video, which is interesting. I chose a file size that I knew we could knock out here in 4 or 5 minutes or so. But you do this on a much bigger video, it'll take longer, but it'll take a hell of a lot longer if you're doing that on a single node as opposed to on all the nodes in the cluster. Yes, sir?
You join them together at the end, and there's something you call the transcoder with a copy parameter or something?
Yeah, exactly. So that command is in the bottom of the, here, let me get this, I'll get this back up here in just a second. Yeah, so there's an avconv command at the end that then sews them back up together. It's at the very bottom. Only the master node has to do that job. So when the master node's done with its job, it knows that at least one of the nodes is done, and it waits for all the rest of the nodes to be done by checking in every 4 or 5 seconds to see if everyone has touched their done flag. And then there's an avconv command that concatenates them all together. Frankly, that was actually the hardest part of writing that bit of code, right? I've done a bunch of parallel processing code, and that, like, touching flags in an NFS directory is the old school way that we've been doing that since, like, Beowulf clusters in the early 2000s, right? Just everyone reads and writes into a directory and touches a flag when they're done. The hardest part was actually the figuring out the somewhat Byzantine interface of ffmpeg and avconv to figure that out, or to figure out how to put those files together. And then sorry, this is what you get for running bleeding edge, latest and greatest unreleased Ubuntu. But look at that. We're right back to where we were because we had our entire session saved in a tmux window. Oh yeah, so we're going to look at that source code. So examples, transcode, hooks, transcode, and then at the very bottom. So this is how you concatenate it back together. You run avconv with the concat command, and you can actually concat a lot of different videos using this if you've got everything lined up correctly. Some things are serial streams and some things are not. You can only concatenate streams of video. So the other important aspect is in here, these 2 bits right here together. The fact that we're spitting this out to a stream consumable video, and if we do that, then we can concatenate. And so that's sort of the magic 2 parameters that I'd encourage you, if you're curious about, to go and read the avconv man page on this parameter and that parameter, and then take a look at what's required for concat. You look confused. I'm sorry. This is not. Yeah.
If you have an MPEG stream like that, sometimes you literally can just concat.
Sometimes, yeah. If it's the right MPEG stream, yeah, you can just cat, and then you can pipe those to MPlayer and just watch them all in series. What I can tell you is that if you leave off this piece, you don't end up with an MPEG stream. Oh.
Address time code?
Time code.
Yeah.
Time skew?
No, time code markers. Does it lose
Good question. I don't know the answer to that question. I'm sorry. That might be we may have some information about that in the log files.
You mean for seeking? Yeah. That's usually generated at the end of transcoding. The seek table blinds at the end of the file.
Yeah. So let's pull up the log and see if we have any information about that in the log file. So, oh, we've got our big buck bunny as well. That one might be a good one to see if we can see the break. Let's take a quick look at this first. So logs. So this is our concatenation job. So this is the bit that runs at the very end, where we concatenate all of our different pieces together. Can you tell me a keyword I might search for to see if the time data is in here? Time code. Oh, code rush. TC. No hits here. I do see I have some continuity check problems, so this would be a case where I'd want to go and be very careful about making sure this video is what I expected it to be before I, deleted the source videos or something like that. Let's try the other one we did in the background here. This one's a little cleaner, a little smoother. And let's do a little bit of math and figure out. So it's 10:02. So 10 times 60 plus 2 is that, divided by 7 nodes. So about at 86 seconds, which would be a minute 26, we'll have our first theme. All right, watch very carefully. So it looks like we have our sounds off a little bit there. All right, so yeah, it's not perfect yet, but we're getting there. It's fast. It's not perfect, but it's fast. You're right. That's true. So if the audio is that's a fantastic question actually, and something I've got in the to-do. We could actually do the audio transcoding separately, and that might be a safer way of doing it. We could do all the audio transcoding on one of the nodes or on another node. The audio is typically very fast to transcode. We will want to make sure that we get the audio, like in this case, from OGG to AAC or something like that, so that we come back to the right combination of formats. But that's a fantastic suggestion, and something I've got in the to-do list right now is to actually take the audio out of the transcoding and do that separately, and then put it back together as part of the concat job. And that would probably be a little bit better in the long run.
What's the speed differential from doing it, obviously on this cluster versus doing it in the cloud? How much time, how much longer would it be?
Yeah, it's a great question. So I've benchmarked this. These nodes run about as fast as M1 extra larges or M3 extra larges in Amazon, which is Amazon's equivalent of 4 cores, 16 gigs of RAM, and SSD local storage. And so the question is really, how much are you willing to pay? You could run it. You can do it. If you can shell out, whatever, $7, $8 an hour, you could run it on one of their cluster compute with NVIDIA GPUs and probably not even need the parallel transcoding. Just do it all on one giant instance. You could do it on a whole bunch of smaller instances, M1 smalls or something like that, which run a little slower than these. So it's really about choosing which instance size, and that's mostly a cost consideration. Nate?
So have you shown this to people at Digital?
Yeah, just over email. Like I have a blog post about it. I send it to them, and they said, "Hey, that's cool. We'll take a look at it." You know. Well, that's all I have. Thank you very much for coming, and appreciate the feedback. Thank you.